Hey everybody, Gabe Jenkins back with you. This is drawing number 15. You're going to see it's this is I think these are going to probably start to feel somewhat easy for you now, because we're really getting the hang of like seeing a more complex shape and breaking it down into its component elements, right? And so what we got here is pretty straightforward, right? You can see a rectangle with some filleted corners, and all the fillets are one. You can see kind of what could be a bigger rectangle. Everything around it is got a distance of 1 between here and here. So we know we can make that with an offset of the whole shape, right? We know how to offset lines. Remember, if you just pick a whole shape, like a rectangle, it offsets the whole thing. It makes the whole thing bigger or smaller by a specified amount, right? So we can start. We can start by making a rectangle and a bigger rectangle that's offset, filleted all the corners. And then all we have to do is kind of figure out how to make this little jutting out part right here and that little jutting out part right there. They give us the dimensions of where everything is, right? But you might have to look in different parts of the diagram, which is slightly tricky, but not too tricky, right? So we can assume some level of symmetry that is the same going down from the middle as it is going up from the middle, same left from the middle as it is right to the middle. So we know that the center point of this circle is 7.8 units over, we'll assume it's inches, 7.8 inches over this way. And even though it doesn't tell us how far down it is, it does tell us how far up this one is, and we'll just make the assumption that it's the same on both sides, because there's no reason to assume that it's different unless they tell you it's different, really. But sometimes it's not always right. But anyway, we're going to make the assumption on this one. So the center point of this circle, both of these circles, is 7.8 over to the left from the origin, and it's 4.8 inches down from this center horizontal construction line we're going to draw. At that point on each side, we got two circles we're going to make. We're going to make one of them is going to have a diameter 2, and one of them is going to have a radius of 1.4 or a diameter of 2.8. And then once we got those two circles in place, all we kind of have to do is join them, join this line to that outer rectangle, and then we're going to draw this curve right here. What I want you to notice just really quickly is that anytime you see a curved line like a circle or an arc that blends almost just like perfectly, seamlessly, fluidly into a straight line, that is an effect that you can achieve with a tangent line. That's the whole point of a tangent line, is that it's a straight line that intersects with a circle or arc at exactly one point, right? And so it'll be like right here is going to be the point where this curved line turns into a straight line. Same thing here. Straight line turns perfectly into a curved line, and it's going to be achieved by using tangent constraints. So this is going to end up just being a line we draw with a tangent using the way we've done before, which is click on the shift, click right click, and then click on the element we want it to be tangent to. I'll show you in the walkthrough. And then here we're going to achieve this by doing a special kind of circle called a tangent radius circle, and trim away the parts we don't want. And that's about it. All right. I think you're going to find this one pretty straightforward as well, and not take that long. All right. I'm going to walk you through it in the walkthrough video in a little bit. All right. Have a great day, everybody. Good luck.